Learn cybersecurity in no time. Hello everyone, welcome back to That Cyber Guy. So in our previous video we discussed IP addresses, but today we are going to discuss subnetting. So imagine that you have a big neighborhood, and each house in that neighborhood needs its own IP address or its own address. So this is how devices they are connected on the network, like computers and smartphones. They need a unique IP address to communicate with each other. Now the other scenario is, let's say that this neighborhood is growing and it becomes challenging to manage all the houses with just one big address range. So this is where subnetting comes in. So subnetting is like dividing the neighborhood into smaller blocks or sections. Each block is a subnetwork, that separated the houses per se or the devices. So as a summary, we can say that subnetting is like organizing and securing a neighborhood of houses or IP addresses by dividing it into smaller blocks. Each blocks or function, they work independently and they promote efficiency and enhance security. So now we just talk a lot. We can open our browser now. You see that we have the subnet right here. You can come to Wikipedia as always and just read and read. But as you can see, this is very different because this doesn't make a lot of sense. Because this is how subnetting is. Many times it doesn't make sense to people. This is why we are here today, to give you some clarity. Alright, so now what we're gonna do, we'll probably have to do some math. So what we are going to do, okay, we can just, I can open my paint here. So what we're gonna do, okay, imagine that we have, let me just make I don't know if I can make it smaller. We have the IP address, okay, 192, I can say IP. Going in the old way. Okay, the IP address that we have is 192.168. That we can say that 1.0, and then I'm trying to create space, and then we want to subnet it. So this is how we call it. We want to subnet it, and then a subnet mask, it determines the size of each subnet. So it's represented by a set of numbers like 255.255.255.0. As you can see right here, we have a bunch of 255. So soon they're gonna make sense to you. So I can say my subnet. I'm trying to make it so small. My subnet is 255 that 255 that 255 that 0. All right, so now what we have to do first, we have to convert this into binary. So to convert this into binary, what we can do, we can just take each octet. This is an octet, and this is one, and this is one, and this is one. So an octet has 8 bits. So if you come to Wikipedia right here, you're gonna see all the information. But what we're trying to do, we're trying to just make it make sense for you. So now what we can do, we will need to convert this into binaries. So to convert this into binaries, we are going to convert 192 and 255, the first subnet of each one of them. I can say that, IP equal 192 because we are just converting only the first subnet, and the subnet can just we are just converting only the first octet, the first three numbers that you see, 255. Okay, cool. Now if we want to convert 192 from decimal to binary, what we can actually do, we can actually go to the calculator. If you're on Windows, go to the calculator right here, and then we're gonna wait until it loads, and we go to the hamburger menu, and then we go to programmer, and then from here it's on decimal. I want to convert 192 into binary. So 192 into binary is 11 with about 6 zeros. Okay, now I can say, I'm going to put the right here, say 11 with 6 zeros. 1, 2, 3. It doesn't look pretty, but you guys get the idea. 1, 2, 3. Now what I'm going to do, I'm going to do the same for the subnet. I'm going to convert this into binary, 255. Okay, gonna come here. Make sure that you select what you want to do. For example, you can put it into octet, binary, but I put it into decimal because I'm typing decimal. So 255. So 255 in binary is 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. Good. So now I can come back here for my subnet. I can just put 8 ones. 1, 1, 1, 1, 1, 1, 1, 1. Okay. All right. So now what we're gonna do, the step 3 is to do something called bitwise in operation. So the bitwise in operation, what it is, so we are going to put them on top of each other. So, and then I'm going to put the binary of the 192. Okay, we know this was 60. And then I'm going to put the binary of the subnet, which is all of them, they were 1. And then we're going to do the bitwise operation. So when it comes to bitwise operations, so whenever you see a 1, it's going to be a 1. If there's a 1 for the binary part, like for the IP address, if there's a 1, it's going to be a 1. If there's a 1 in both sides, otherwise it's gonna be a 0. For example, for the IP address, which is a 1, I can say I here and say S for the subnet, because there's a 1 at the top, 1 at the bottom is a 1, and the 1 at the top, 1 at the bottom is a 1, and because there's both of them, they are not 1, all of them gonna be 0. So now if we just go back, we can just convert this into decimal. This is 11 and 60. Now we have to just select binary, 11 and 60, which should give us 192 as a decimal. So this gives us 192. Now, this gives us 192. What we can actually do, the 192 that we have, we can actually say that, if we are to just, assign, subnet network to this, we can say this IP address is going to be 192.0.0.0 with the subnet mask of, let me see if I have space, of 255. That 255. That 255. That's 0. Alright, now this is kind of messy. What we can do, we can actually just open a new one. No, okay, good. So now we have the IP address, we have the subnet mask, but now how many addresses that can be connected to this? Because in other term, we can actually write this as give me 1 minute, let me open this. You can write this as 192, the actual IP address, in a very professional way. It's gonna be 192.1.0. Sorry, that's 0, and then -24. Because why it is that 24? Because 255.0/24. This is what Wikipedia was trying to explain you right here. Wikipedia, if you go right here, you see 255. Yeah, 255.255.255.0 is -24, and then they say that 256 addresses can be connected into it. So now let's just demonstrate how 256 IP addresses will be able to connect to this. So now if we go back right here, you have a big mess. Give me a second. Okay, I don't know why this doesn't show up. There we go. Okay. So now this we're gonna have about Wikipedia say we're gonna have about 256 IP addresses, because there's something like the -24 notation. As I explained, is indicate that the first 24 bit of the IP addresses are used for the network, leaving 8 bits for the host address. Now those dash, if you go back to Wikipedia, we're gonna see that it goes until 32. So now what this is 31, but it's that it is 32. But now what you can actually do, you can actually to find the 8, what you have to do, because with 8 bit for the host, there are 2 bit to the power of 8. So for example, when you get 32 minus the 24, okay, this is what gives us 8. And then for that 8, to just calculate it, it's gonna be 2. If we go back to our calculator, we're gonna change it to scientific, because it's gonna be 2 to the power of 8. Give us 256. 256 minus 2, which is gonna give us 254. Yeah. So we have 256 minus 2. The reason why we have minus 2 is because sometimes you have to just some of them, they are reserved. Yeah, you have 2 addresses within the range that are reserved. For example, the first address will be 192.0.0.0, which is the network address. This one is reserved, and the last address will be like 192.0.0.255. which is the broadcast address. So now when you do 256 minus 2, it's going to give you 254 devices that can be connected to that network. Now, if you go back to Wikipedia, they're gonna 256, and then the host is 254. So because those, as I explained, we have 2 reserved IP addresses. Yeah, I hope this helped, guys. This is basically what subnetting is. I know that subnetting is very difficult. For many people, it's very hard to understand, but I was hoping that I just simplify it for you today. Make sure that you like, subscribe, and share, because we are just covering the overall aspect of IT. Thank you so much.